Descartes' rule is going to help us determine possible number of positive, negative and imaginary zeros. So let's work on this problem. So first we will check sign changes in fx. So first term is positive, then second term is negative. So one sign change. Then negative to negative, no change. Negative to positive, again a change. Positive to negative, change. Negative to positive, one more change. So fx changed the sign 4 times. It means number of possible positive zeros can be equal to number of sign change less than the number of sign change by even integer. So it can be 4, which is number of sign change, 2 or 0. So you can have either 4 positive zeros, 2 positive zeros or no positive zeros. Similarly, you will check the sign change for f of negative x. So in place of x, we are substituting negative x, which gives us negative x power 5, negative of negative x power 4, negative. So wherever I see x, I am substituting that by negative x, which gives us negative x power 5, x power 4, negative times negative is positive, x cube, plus 32x, negative times negative is positive, plus 320. And we will check the sign change again. Negative to negative, no change. Negative to positive, one change. Positive to positive, no change. Positive to positive, no change. Positive to positive, no change. So number of possible negative zeros can be number of sign changes in your f of negative x, or you reduce every time by 2. But this time if you reduce by 2, you will get a negative number. So number of possible negative zeros will be 1. The total will be equal to your degree. Degree here is 5. If a polynomial have degree 5, you get exactly 5 zeros, which means rest of them are going to be imaginary. Means iota term is non-zero. So 4 plus 1, we already have a total of 5. 2 plus 1, and we want a total of 5. So imaginary zeros will be 2. 0 plus 1, and we want total of 5. So imaginary zeros will be 4. So this way, using Descartes' rule, we can find out possible number of positive, negative and imaginary zeros. Also, if we want to find out the upper bound and lower bound for our zeros, We will say b is upper bound of zeros if b is the largest possible zero, or all the zeros are less than or equal to b. We will say a is the lower bound if all the zeros are greater than or equal to a. So how will we find our upper bound and lower bound? Let's understand that with an example. Let's say we have a polynomial given by 6x power 4 minus 17x cube minus 12x square plus 23x plus 12. And we want to check if 4 is the upper bound and negative 2 is a lower bound. So if you are checking for a positive number, first condition, if your c is positive and you are checking if it's a upper bound, so perform the synthetic division, bring down c as it is, going upward you will multiply by 4, going downward you add the term, going upward multiply by 4, going downward add the terms, going upward multiply by 4, going downward add the terms. So if your number is positive and all the terms in the quotient and remainder are positive, so we say if c is positive and both remainder and coefficient of quotient are non-negative, means 0 or greater than 0, then c is upper bound of your zeros. So we will say 4 is upper bound, 4 is upper bound for real zeros of px. Similarly, if you are checking for a negative number, for positive number the result is for checking upper bound, for negative number the result is for checking lower bound. You will do the synthetic division, bring down first term as it is, moving upward multiply by negative 2, going downward add the terms, going downward add the term, going upward multiply by negative 2. That gives us a remainder of 150. So if you are checking for a negative term, if you are checking for a negative number and coefficient of quotient and remainder alternate in sign, you will say c is lower bound for real zeros. So we are checking here for a negative number. The terms in quotient and remainder alternate the sign. So you will say negative 2 is lower bound. Negative 2 is lower bound of real zeros. In any other case, we are not concluding anything. If the signs don't alternate, we are not concluding anything.